Hi all, and welcome to our lesson on electrical circuits. So the cell. A cell stores chemical energy and transfers it into electrical energy when the circuit is connected. Now your last couple of lessons were all about energy changers. The energy cannot be created or destroyed, but is simply changed from one form into another. So here we've got chemical energy changing into electrical energy. But this can only happen when we connect up a circuit. When two or more cells are connected together, we can then call this a battery. A battery stores chemical energy. Now the battery's chemical energy is used up pushing a current around a circuit. So what is an electrical current? An electric current is a flow of microscopic particles. That's particles that we can't see, and they're called electrons. And they flow through wires and components, and they have a negative charge. And we can see that here. We can see the currents flowing through the wires. Now, in which direction does the current flow? Which direction do these electrons flow? Well, the current or electrons flow from the negative terminal, which we can see here. It's a negative terminal, to the positive terminal, which we can see here. Now, electrons are negative in charge, and they're repelled from the negative terminal and attracted to the positive terminal. Opposites attract. So your negative electrons are attracted to the positive terminal. So let's have a look at simple circuits. So below we can see a simple electric circuit. It has a cell, a lamp and a switch. Remember, the cell stores chemical energy. So then we've got the cell, the switch and the lamp. To make the circuit, these components are connected together with metal connecting wires, and this completes our circuit. When the switch is closed, the lamp lights up. Now this is because there is a continuous path of metal for the electric current to flow around, and remember, the electric current is made up of electrons, microscopic charges. Now if there were any breaks in that circuit, the current would not flow and therefore the lamp would not light. So remember, the electrons or electric current needs a continuous path. Now we're going to practice drawing a circuit diagram. Now, scientists usually draw electric circuits using symbols just to make life a bit easier. So what would the symbols be for a cell, a lamp and a switch? So for a cell, we start with cell. You draw a straight line and a thicker line here. So that would be the symbol for a cell that stores electrical energy. Okay, and a switch would look like this. We can see it that's open just now, and we know it can also close over to complete the circuit. And a lamp would look like this. So let's have a wee look at more symbols. So here we've got a cell, a battery is two cells together, a switch, a lamp, a buzzer, an ammeter, a voltmeter, a motor, a resistor and a variable resistor. Now we are familiar with the cell, the battery, the switch and the lamp so far. So let's do some show me and see how we've got on. So the cell stores what kind of energy and transfers it to what kind of energy when a circuit is connected. Well, the cell stores chemical energy and transfers it into electrical energy when a circuit is connected. Remember, this will not happen if we have any gaps in the circuit. When two or more cells are connected together, we call this a battery. An electric current is a flow of microscopic particles called electrons. In which direction does the current flow? Current flows from the negative terminal to the positive terminal. Remember, the electrons are negative, so they're repelled against the negative terminal and attracted to the positive terminal. So they flow away from the negative and towards the positive terminal. What is this a symbol for? A battery. Two cells joined together. And what's this a symbol for? A lamp. And what's this a symbol for? Well, that would be a cell. And this? A switch. Now you're going to practice drawing a circuit containing a lamp, a cell, and a switch. So go and get a wee piece of paper and have a go. And we'll check your answer in a wee minute. If you want, you can pause this video. So let's have a wee go. Do you remember the symbol for the cell? So we've got a straight line and a thicker, shorter line, and we're connecting it to wires. And then what I'm going to draw is the bulb here, the lamp here, right along here, and I'm going to put in a switch. Now let's see how our circuit compares to the answer. So what we should have is our symbol for the cell connected up to wires, and then the symbol for the lamp here, and our switch.